In this video, we'll discuss the following points and learn to draw circles in perspective, unlocking the ability to finally draw the 5 3D primitives. Take things slowly. Make sure you spend 1 hour a day practicing the things you learn here until you can do them all. All the stuff you learned about one-point perspective in the previous videos will be used here, so make sure you continue to practice them and see how they apply to this lesson. One thing we haven't discussed yet is circles. We've only dealt with squares, and that was intentional because both squares and circles are the same shape. What's that? You don't believe me? Well, look at this. If we draw a square, and it does need to be a perfect exact square for this example, then we can place a circle perfectly inside it, and its tangents will touch the exact midpoint on each of the square's edges. The opposite is actually a more useful approach though. You see, we can draw a circle using a template or compass and actually draw straight lines that tangentially align with the circle to make a perfect square. No measuring required. This is another one of those tricks that works at any angle and in any perspective, so we can draw a square plane in perspective and then place the circle inside it. And this is the easiest way to manage placing circles in perspective. We can also draw an ellipse and turn it into a square in perspective. When a circle is in perspective, we call it an ellipse because the distortion it undergoes makes it wider in one axis than the other. You can experience this for yourself by placing a cup or similar object on the table in front of you and moving your eye level up and down. I think that's pretty intuitive for most people to grasp. This variation in width is known as the degree of the ellipse because it's measured in degrees, just like an angle. A 90-degree ellipse is a perfect circle, and a 5-degree ellipse will virtually be a flat line. What catches people out when drawing freehand ellipses is what degree is the correct one to use in perspective, and that's why I recommend drawing squares and placing the ellipse inside the square. If you use the skills from the previous lessons to make measured squares, or are skilled enough that you can generally eyeball them, then you just draw a square in where you want the ellipse, and the ellipse will fit perfectly inside it, to the correct exact degree required. When we talk about ellipses specifically, the long axis is called the major and the shorter one is called the minor. We use the minor axis to place ellipses in perspective. This is very important for making them look correct. In fact, if you are failing at drawing ellipses correctly, I would wager this is the reason why. The minor ellipse works like the axle of a car wheel. If I cut a circle out of card and poke a cocktail stick through the center, we can see that as I rotate the circle to make it an ellipse from our viewpoint, the axle is actually always the minor axis. This means we can use it to perfectly cut the ellipse in half along its shortest axis. And that's a handy trick to use to test your ellipses are correct, and also to assist you in placing them. If we want to place an ellipse in perspective, then the axle for the ellipse is the line running to the vanishing point. Here in 1 point, that's very easy, because remember, all front-facing shapes remain orthographic. That means a front-facing circle will always just be a circle. You'll see that nasty distortion occurring if you use this outside the cone of vision. For more complex perspectives though, we need to make a perfect square, then find the middle, fire a line from the middle to the correct vanishing point, and appreciate how this is the axle for the circle we want to draw. If I trace this ellipse and the axle and show you it like this, as if it was orthographic, then you can see that the axle always cuts the ellipse perfectly down the minor axis, and that's the golden rule for making sure this is set up correctly. It's easier to understand why this works by looking at your card model. If your axle isn't perpendicular to the face of the ellipse, then you don't have an axle correctly shooting to the vanishing point, and your minor axis is in the wrong place. Ellipses and circles are tough to draw. We've all seen that one episode of SpongeBob where he draws a perfect circle, right? Well, I'll straight up tell you that nobody draws perfect circles and ellipses. We can sketch out close enough to perfect ones, but we always have to tighten them up for finished drawings using tools. The main tool for doing this is an ellipse template, and they're available in various sizes, and they feature the major and minor axes as dots on the outside of each ellipse. We simply align the minor axis on the ellipse template with the axle running towards our vanishing point, and this gives us the ellipse we want. The issue with these is that they're only available in certain degrees and certain sizes, so what if you have a 43-degree ellipse that you want to tighten up? Well, a full set of ellipse templates will often contain a near enough value you can use, like 40 or 45 degrees, but they also cost a lot of money. Another option is an ellipsograph, which is kind of like an adjustable ellipse drawing tool, but it's again expensive. If you really need to make a custom ellipse, I would suggest printing one out and making your own custom template from card. For sketching purposes though, we can generally get good enough results by training up our skill in drawing ellipses freehand. You can train this with or without using squares to fit them inside. In fact, a good exercise is to just map out a few lines going towards a vanishing point and then trying to draw ellipses inside the foreshortened plane you now have. When we draw ellipses and circles, all the same rules apply as we used for drawing straight lines. We want to generally swing from the elbow, and we can ghost the shape in first to have a few practice swings. The idea is to practice this at both narrow degrees and for perfect circles, and to channel our inner SpongeBob to get as close to perfect as possible. But remember, you do not have to be perfect. Good enough ellipses will normally do, as long as they are placed correctly in perspective. I actually have another method which I use, and I'll share it here, and it gives me better results generally. I start with a square. I then draw in one half of the ellipse, first ghosting it with a practice swing and then going for it. I then do the other half. Sometimes I'll do a quarter at a time and I'll rotate the paper so that it's always as easy as possible for me to put down. In digital programs, this is even easier. We just use the built-in tools to make a square with a circle inside it, and then use the transform tools to place it in perspective. No drawing required. The idea of using planes to map ellipses is very powerful, and it works in any perspective framework. But we can also use them to mirror curves. Let's say we want to draw a Wild West scene and make a saloon door with some scroll work on it. We can place a plane in the doorway and divide it in half with the tricks we know. We then draw the door we want on one side. We do this by generally plotting out dots we want the curve to hit in a faint tool like a pencil, and then join the dots together. For tight curves, swinging from the wrist might be better than the elbow, so be sure to play with that. We've seen how we can subdivide squares in a grid-like fashion, but there are actually many ways to subdivide squares. For example, we can radiate lines from down here in the midpoint at the bottom, and where these lines hit our created curve, we can mirror them across to map them to the other door. This is how we perfectly reflect curves like arches, half-pipes, and tunnels in perspective. Once again, there are tools like flexi-curves and French curves that exist to help you tighten your curves up when drawing things like vehicles. If you can draw ellipses, then you can now draw any primitive, and actually have all the skills now required to draw literally anything. The primitive forms are the cube, the cylinder, the cone, the pyramid, and the sphere. Cubes and boxes you know, and a cylinder is just a box with an ellipse at either end. You mark the ellipses, join them together, and you create a cylinder. A cone is a box, but with an ellipse at one end, and a point in the dead center of the opposite face. We connect the edge of the ellipse to the point on the other end, and we have a cone. Pyramids are the same as cones, but instead of an ellipse, they feature a square on the bottom. Spheres are actually the easiest of all. If we make a box, then we create planes that intersect each direction in the middle of the box and draw ellipses on those. Generally, unless distorted, we can then just use a circle template or compass to make a circle that touches the edges of the ellipses. In fact, all spheres in perspective can actually just be drawn as circles. The reason we need the ellipses in a box setup is to help us actually see them as three-dimensional instead of two-dimensional. But after a while, you become skilled enough to just draw a circle and then draw the ellipses around it like an equator, making our brain perceive it as a sphere in 3 dimensions. We'll revisit ellipses again in a future lesson to see some more advanced uses of them, as well as these primitive forms, but for now it's time to experiment with them. Can you draw ellipses in one point and appreciate how the axle of the circle is the minor axis, and that this is how we correctly place them in the scene? Can you draw a variety of ellipses, both freehand and using tighter construction methods? Can you create a fancy archway or door design and mirror it across to make a pair? Can you draw the 5 primitive forms in various shapes and sizes in one-point perspective? So to recap, you learned that squares can be used to draw circles, and circles can be used to draw squares. That the minor axis is what we use to place circles in perspective, and this behaves like the axle of a wheel. That we should practice freehand ellipses. Also be aware that generally tools are required to draw them for professional work. We can draw curves of any design and mirror them using grids and radiating lines. And that we can use squares and circles to draw any of the 5 primitive forms in 3D. Make sure you can do the following before moving on to the next video. To make the challenge easier, build your own wheel and axle and grab something like a coffee cup and try to observe how the things I described in this video work in the real world. How does the degree of the cup change as you stand above it or at eye level with it? Can you see how the cup is a cylinder and how the top and bottom circles will have slightly different degrees? We can make these perfect by using our perspective skills to make a floor grid and then map the cylinder out. The ellipses will then be perfect, but you will need to have mastered the skills from the previous videos. To make the challenge harder, try and draw some still life compositions. Find objects that are cylindrical or pyramids or spheres and draw them from life. Then translate the scene onto a one-point framework, and you draw it with different cones of vision and see how they distort. These sorts of challenges are tough, but they'll force you to jump between seeing perspective in the real world around you and depicting the real world on a perspective grid on paper, and that will make you notice all sorts of things. Don't move on until you can comfortably draw ellipses and primitive forms. We'll look at two-point perspective next time, and see how adding one more vanishing point changes things. Seriously, make sure you can do these things before moving on. If you want people to practice with, I recommend joining this channel's Discord server, where you can ask questions, get more challenges, and reinforce your learning amongst friends.